Okay, this will be a fairly short recording. It relates to Section 4 of Chapter 15 of Young and Freedman's University Physics, again, but physics is the same no matter what textbook you're using. And this is about the speed of a wave, that is the speed with which a wave, say, is moving horizontally, for example. Not the transverse speed, but the speed it's propagating, as it were, through a medium. The section shows this formula in two different ways, so it actually gives kind of two proofs or two demonstrations of this formula, but what you really need to know, probably, I mean, you might have a torturous professor who wants you to know the proofs, but this is the main thing to take away from this section. The velocity or the speed of a transverse wave on a string as it's propagating, its propagating speed, is the square root of the force, the tension force, as it were, the restoring force, divided by mu, which is the linear mass density. Again, what is F? So F is the tension force. So when you start off with a string, there's a tension that's keeping it horizontal. The force of, making the wave, that's not what we're talking about here. We're not talking about Fy, the force that makes it start a wave. We're talking about the force that wants it to stay taut, that is. The restoring force that wants it to settle down there, string, that wants it to go back to being taut. That's, or taut. I don't know. Let's call the whole thing off. But anyway, that restoring force, that tension force, that's what the F is that we're talking about here. And mu is the linear mass density, or the mass per unit length. So if you're dealing with string, the mass of string per unit length of string. And there you have it. This section does this for several pages, but most of it is just proving this formula. And that's basically what you need to know. Velocity equals the square root of that restoring force, or the tension force, say, divided by mu, which is the linear mass density. So in general, the velocity of a wave, the propagation speed of a wave, is going to be the square root of the force wanting to restore the system to equilibrium divided by the inertia that's resisting the return to equilibrium. So mu, the linear mass density, is basically resisting, is a body in motion wants to stay in motion, and so that linear mass density is going to be resisting the restoring force. Okay? Interesting example of a bucket. You've got a bucket in a well, 20 pounds, I think it says, or something like that. And it's asking about what this wavelength of a wave would be if it jostles a little bit. Okay, short section. I said it'd be short. I'll keep it to it. Velocity equals the square root of F over mu.